Okay, I'm just going to refresh your brains on how to find the area under the curve using the right endpoint rectangles. Now, you do not need the graph for this. The graph is here, and that will come in handy. But all you need is this right here. So since this is a definite integral, ooh, and I left that out for the last video. I forgot to put the B in the A. All right. Remember, the A is the lower bound, and the B value is the upper bound. That should make sense. The smallest value is the lower bound. The largest value is the upper bound. Okay, so you can ignore the picture, and maybe sometimes that's better because it's easy. Like I will skip a line a lot and put the incorrect value over here. So sometimes it's best to plug this in the calculator. So again, you don't have to write this down. This would be something that you just type into the calculator. So -2 squared is 4. That's plus -4, so those cancel. So at -2, we're up at 3. All right? And then at, oh, I left off 1. I'm like, there should be 5 points there. There we go. Okay, and then where are we at? -1. I'm going to put -1 up there now. So that gives us 1, subtract 2, plus 3. Well, 1 plus 3 is 4. 4 subtract 2 is 2. It looks like, at least for a little while, we're going to be counting down by 2. So I'm going to erase that. Again, you put 0 in. Well, 0 is easy. You're back up at 3. At 1, well, at 1 we have 1 plus 2 plus 3. Well, that gets us up there to 6. And then at +2, we're at 4 plus 4. That's 8 plus 3. We're up there at 11. Okay, this is the rightmost points. So this is what you're going to be doing. Remember, here, let me change this. We're looking at the rectangle that goes from here to here. And now we're looking at this rightmost point right there. Okay, let me change the color again. Then we have this rectangle. There's the rightmost point. I'll go back to yellow because it'll be hard to see the other. Then we have this rectangle. There's its rightmost point, or its height. And then finally, we have this rectangle. All right. The other thing you're going to do is remember this is the width, and then those are the length. So we have from here to here, that's a length of 1. A width of 1, a length of 2. We have from here to here, a width of 1, a length of 3. Length of 1, length of 6, length of 1, and then we've got that 11 right there. So that's all. I'm going to have to erase a bunch of stuff now. Sorry about that. Oh, I can do it over here. So now what we have is width times length. So, well, you guys are calculus. 1 times 2 is 2. 1 times 3 is 3. 1 times 6 is 6. 1 times 6 is 11. So 3 and 6 is 9, plus 11 is 20, plus 2 is about 22 units. That's it. So that's the easiest way. If this would have been the leftmost point, then instead of going down towards the right, that would have been the leftmost point. For these two, that would have been the leftmost point. For these two, that would have been the leftmost point. For these two, that would have been the leftmost point. So we would have had 3 plus 2 plus 3 plus 6. So 3 plus 2 plus 3 plus 6. So we would have had 6 plus 6 is 12 plus 2. So look at the difference between a right point area, which is 22 units squared, and left. All right. And then if you actually did uh, a regular integral, since we have that function, between a definite integral, we could go ahead and figure out which one is actually closer. All right, that's it for this one.